Hello, my mathematicians. This is Miss Foster with Math in Focus, 3rd grade, Chapter 17, Lesson 1, Lines and Angles. Friends, I am so excited to be doing geometry with you. It is my personal favorite math subject because it is the math of art. There's a lot of vocabulary here, and so if you love to read, if perhaps reading has felt like a strong suit to you, then get excited because your ability to learn and remember new words will be super helpful. There are just so many new words to learn in geometry. And we're going to get ready to do a lot of fabulous drawing. So let's go. So the first term that we need to learn is point. And a point is an exact location in space. It is represented by a dot, a period, just a point. And in geometry, we might say that the point has 0 dimensions. It's 0D, which when I write it there, it looks a bit odd, and that is. But with a point, it's literally meant to be just that one exact electron in space. Mathematicians imagine them as having no width, no height, and no depth at all. They're just a location. So that's a point. Now, because points are so itty-bitty and teeny-tiny, they are named with itty-bitty, teeny-tiny names. In this case, a letter. So you can see point A here. And if this were my paper, and I were doing this for myself, on my paper, I also could create a point and name it A. What I cannot do is name any other point on this paper A. I would have to label this point B. And the reason why is that it's a different location. But for the purposes of me doing my work and you doing yours, you can put point A on your paper as well. On any paper, all points must have a different name, and they're so itty-bitty that that name will always be a letter. Now here's another one where you might think, oh wait, Miss Foster, I already know what the word line means. And the answer is yes you do, but maybe you don't. So a line is a straight path. That part you already knew. But here's the tricky mathematical thing. For mathematicians, when they say line, they mean that the line goes on forever and ever in both directions. No matter which direction it's headed, no matter if it's going like this or like this, it just keeps going in opposite directions forever and ever and ever. Like right through the earth, if necessary. So they show that by putting these arrows on the end of where they have drawn the line. Now, if we want to name this line, we could say that this line is passing through points A and B. So we could name it AB or line BA. And the way that you will do that in middle school is you will write the 2 letters of the points you are referencing, and above them you will put a little line with arrows. Now, when you're drawing a line on your paper, a line has to be perfectly straight. So you're going to want to use a lot of these measuring and drawing tools that provide you with a straight edge. For example, here is a protractor, and I could use it, and I'm not going to do it perfectly here, to draw a straight line. And you can see, because it's in the electronic space, it doesn't really help me. But when I'm doing it in real life, I can take my pencil and run it right up against there, and that straight edge will help my line to be perfectly straight. A line is never curvy. It is only perfectly straight. In real life, I could also use this ruler. Oh, look at that. I think it is actually working that way. Oh. And sometimes if in a pinch, I will take a piece of paper and just fold it in half. And that fold will always be a straight line. Now you can see it's not helping me on the screen, but it often helps me in real life. I have been known to just grab any piece of paper, fold it in half, and boom, straight edge. But in real life, there's no way to draw an actual line because it goes on forever and ever in both directions, right? So we always draw line segments. We let you know it's a line because of these arrows. But what we generally draw are line segments, which means a piece of a line. It's just a piece or a part. And it will always have 2 endpoints. So here's endpoint C and here's endpoint D. And lines and line segments both get to have names that have 2 letters in them. Not really long names, huh? but they only have one dimension. So we'll just let them have a little bit more than that zero-dimensional point. So the way that you would show the name of a line segment is you would write the names of its endpoints. And once again, it does not matter which direction it goes in. And then in middle school, they'll show you how you can put a line segment on top with no arrows, and that will let everybody know you're talking about either line segment CD or line segment DC, and both of them are correct. Now, two line segments can come together, and when they do, they form what is called an angle. In other words, they share the same endpoint right here. So the angle is the space between these two line segments. If they were going on and on forever and ever, it could be between two lines, or a line segment and a line. But they have to share a vertex, which is right here at point H. A vertex is the intersection of two lines or line segments. It's where they meet. Just like when you are driving along the street and you come to the stop sign at the intersection, that's where two roads are about to cross. The point, in this case, is an intersection, and mathematicians often use points for intersections. Now, this curvy part on the inside here, that's the symbol that mathematicians use to let you know that, hey, this is an angle I'm talking about. And you can actually, their little example down here is that you can use your arm to make different angles. Now, do you notice that there's not that much space right here compared to this? And then this way? Those are different angles. And so when we're talking about angles, we're describing how close the two lines are together, really near their vertex. Although we measure it as part of a circle here, and that's why we need the curvy line. But we'll get into measuring angles later. Now, angles show up whenever line segments intersect. So if you look at my square over here, you will notice that there are 4 angles in the square, marked with these curvy lines. In the triangle, you see there are 3 angles. You know, sometimes tri and angle really looks to me like a shape that has 3 angles in it. That is literally what it means. But sometimes we also call a 4-sided figure that has 4 angles in it a quadrangle. Quad is the ancient Latin word for 4, and when we put it with angle, we're saying we have 4 of the angles in there. So our square can be called a square, a rectangle, a rhombus, a quadrilateral, and a quadrangle. Whew, so much there. Now, here we have a whole collection of different shapes. And one of the ways that mathematicians analyze and describe shapes to show their understanding and to communicate with each other is they count things like sides and angles and kinds of angles. So we're going to do a little practice with that here. Here is shape A. It looks like a triangle to me. And how many sides does it have? 1, 2, and 3. So that's 3 sides. How about angles? Well, it has one here, another one here, and another one here. 3 angles. Shape B looks like a rectangle to me. It has 1, 2, 3, 4 sides. And it has 1, 2, 3, 4 angles. What about, I'm starting to see there's a little repetition here. Do you see it? Let's try C. 1, 2, 3, 4 sides. And shape C has 1, 2, sorry, that's not very curvy, 3, 4 angles. Are you feeling like there's a pattern here? Let's try shape D. 1, 2, 3, 4, 5, 6 sides, and 1, 2, 3, 4, 5, 6 angles. You know, we've only investigated a few of them. But I wonder if this is enough for us to notice right here that the number of sides and the number of angles and polygons are the same. I don't know if that's true, but I'm beginning to sense that it might be. So think about that while you're doing your work. Now, we have learned some vocabulary here, and we are going to be practicing in our workbooks on page 173 through 178 to give you a chance to apply that vocabulary. So a point is just a specific place in space. And in this geometrical drawing, I have point T, R, S, I have U and V. There they are. A line goes on forever and ever. So if I wanted to make this a line, I could give it arrows. A straight edge going in two directions forever and ever. Now, if I just want to have a line segment, then I would need to give it two ending points. In fact, I'm going to make these intersections right here ending points. I'm going to call this one E and this one L for Luna, who's sitting in my lap while I record this. A line segment has endpoints, so only this part of it right here is line segment EL. And then we have our angles, which is the space between two line segments, or actually even lines that intersect. This is an angle, and this is an angle, and this is an angle, and this is an angle. So give it a try practicing with these words on your workbook pages. Use the answering key that we are posting so that you can grade it. Get some wrong, go back and figure out and learn. If you get stuck, rewatch this video. Draw geometric models. Here's one right here. Get yourself a straight edge and start drawing, because geometry is the math of art. And send questions to me or to your classroom teacher if you have any. Hey guys, thanks for playing geometry with me. I adore playing geometry and I had so much fun with you. Bye bye for now.